This is Year 13 AS1 Physics 1, and this is just a short revision podcast about projectiles, a subject which a lot of people find difficult, and so I'm just going to go over a few key points about projectiles. Now, the first thing that you would really need to know or understand is just about vectors, how to find the resultant of two vectors. So if you have two vectors and they act at right angles to each other, and you won't get vectors which act at any other angles to each other, then to add those up, what you need to do, you know that the resultant is going to be somewhere in between. Now, what we generally do in physics is we would take those two vectors, close them up into a triangle, like that. And to do that, they have to follow each other end to end. So I've moved this one over here. I could alternatively have moved that one down here. Either one will still give us this green arrow. And so there's your green arrow now. And you should always put arrows onto your vectors to show their direction. Because obviously, a vector acting this way is completely different from a vector acting that way. They may have the same magnitude, but completely different direction. So if you have something like 10, and we'll say 8, no, we'll say, in fact, I'm just going to change that to make that 3 and make that 4. Then you have got 3 here, 4 here, and 3 here. And therefore, to find the length of this green side, then that vector is equal to, use Pythagoras' theorem, 3 squared plus 4 squared. And that's going to give you 16 plus 9. And therefore V is the square root of 9 plus 16, which is 25. And V has got a value of 5. Now be aware that sometimes that your resultant vector may actually be one of these sides here. Just be aware of that. It might be two vectors falling on from each other like that, and that could be your resultant. It's not common, but you might have a resultant which is actually shorter. The last thing that you might have to find is a direction. And you decide, if they just say a direction, you mark an angle on your diagram. And you decide, right, this is the angle I'm going to find. You're best to use the two sides that you were given originally. Because if you've made a mistake with this and you use it in your calculation, you may get it marked wrong. But to find a direction, what you do is you take an angle and you find the size of the angle by using some of your trig identity. So if we take this angle here, then the opposite side to that's 3 and the adjacent side to that is 4. So I'm going to use tan. So the tan of theta is the opposite over the adjacent, 3 over 4, and therefore your angle theta is the inverse tan of 0.75. And I'll just do it quickly in the calculator for you. That gives you an angle of 36.8. We'll round it up to 37 degrees. And that's to the horizontal. And so that's how you find this magnitude and size of your vector. Now, this does all come into projectiles. The second part there then is components of a vector. So if I just go back to that green arrow there, say I had that green arrow and I knew that it was of a length 5 and that the angle that it acted at was 37 degrees to the horizontal. And I wanted to find out two components to that. The components of that would be horizontally and vertically. And so what I would do there is I would draw in a vector triangle, horizontal and vertical to that line, like that. I would put in my angle, 37 degrees. And then I would work out, right, this has got a size of 5. So this angle here, this line here is the opposite side to the 37 degrees. And say I call that just opposite and I call this one adjacent. Then to find that opposite side, I know that the sine of my angle is opposite over hypotenuse. So the sine of 37 degrees is opposite over 5. So my opposite side, if I'm going to work that out, is 5 times the sine of 37 degrees. Then my adjacent side here, I'd have to use cosine is adjacent over hypotenuse, and that means that my adjacent side there is 5 times the cos of 37 degrees. And this is always the case that if I have a vector which I am going to draw in 2 components, then the line beside the angle, i.e. the one that has adjacent in it, is always the hypotenuse. There's my theta. This one here will always be the hypotenuse times the cos of theta. And this one here, that's that way there, this one here is going to be the hypotenuse times the sine of theta. And that's always true for the position of the angle. So the line beside it is always the hypotenuse times the cos of the angle. The one opposite is the hypotenuse times the sine of the angle. And the combination of those 2 vectors gives me a hypotenuse there which has the same effect on the object which is experiencing the force or whatever it is as these 2 individual vectors acting on it. So I'm just straight back here again. So that has the same effect as these 2 acting on it. And so what we've done is we've taken our green arrow and split them into these 2 sides again, and they're called the components of the vector.